Hey everybody, we're going to finish up answering numbers 16, 18, and 22 from this yearly review number 6 worksheet. So number 16, we have Mandy received a paycheck for $400. She put $150 into savings. Well, that's very smart. Put some money into savings. And she spent $190 for the monthly payment on her car. Well, yeah, if you have a payment on your car, you better pay it. What percent of her paycheck is left? Well, we can't know what percent of her paycheck is left unless we first know the amount of her paycheck that remains. So let's figure out, what did she spend? She received a paycheck of $400. All right, she spent $190 and she put $150 into savings. So she didn't spend that technically, but she's designated it for her savings account. So let's add these together to figure out how much of her paycheck is already accounted for. So 190 plus 150, we'll add those together and see what we get. Zeros. 9 plus 5 is 14, carry the 1. 1, that's 3. So $340 of her $400 paycheck, so she's either spent it or else put it into savings. So what does she have left? Well, take the $400, subtract the $340 that is either in savings or spent, and we end up with $60 left over. So $60 remains of that $400 paycheck. What percent of her paycheck is left? Well, it's $60 out of $400. My pen battery is low. We're going to see if I make it through this video or not. All right, so if you just divide, remember the fraction bar means divide. If you just divide these, you're going to have a decimal value, and 60 divided by 400 is going to equal 0.15. And then you move your decimal point right 2 spaces to change it into a percent. You get 15% of her paycheck is left. Now, another way you could do this is, if you want to know what percent is, you need to know what it is per 100. So you could set up a proportion like this. 60 out of 400 would equal what out of 100? Because that's what percent means, per 100. And guess what? 400 divided by 4 is 100. So just take 60 divided by 4 to find that missing value. And it's 15%. Oops. All right, number 18. What is the surface area of this cube? The fact that it's a cube makes this a lot easier to solve. A cube has 6 faces, or sides you can call them. I prefer to call them faces. But they're all identical to each other. And the surface area is like the area of all of these sides. If you imagine this was a box, we're finding out how much cardboard was used to make the box. I'm going to shade in the front here, the front face of this cube. All right, and it's 9 centimeters this way. It's also 9 centimeters this way. It's also 9 centimeters this way. Every dimension is 9 centimeters because it's a cube. So all of the edges are congruent. So if you want to find the surface area, find the area of one face, 9 times 9. But then once you find that value of 81 square centimeters, aren't there 6 faces on this cube? And aren't they all identical? So if you just take 81 times 6 now, you're going to end up having the total surface area of this cube. Isn't this one nice? Because all 6 faces are identical. 6 times 1 is 6. 6 times 8 is 48. We get 486. Area is always square units. So we have square centimeters here. 486 square centimeters. And we're done. That's all there was to it. Now, a common mistake would be to take 9 times 9 times 9 and get 729. That would actually be the volume of this cube, or how much liquid it could hold if you were to fill it up with liquid. Okay, but we wanted the surface area, so find the area of one face. 9 times 9 is 81. And then take that times 6, since all 6 faces are identical. And that's our surface area, 486 square centimeters. And one last question, number 22. Kenny has walked 0.8 miles from his house toward the baseball fields. If this is 2/3 of the distance to the baseball fields, what is the total distance from his house to the ball fields? The easiest way to do this problem would be to make kind of like a little line here, like a number line almost. All right, so here's his house right here. Here's the ball fields right here. It says he has gone 2/3 of the distance to the baseball fields. So we're splitting this into thirds. I'll put 1/3 here. I'll put 2/3 here. And then 3/3 would be all the way. Now I know I didn't make these perfectly evenly spaced in my drawing, but it also says 0.8 miles is how far he's gone. Okay? If 0.8 miles gets you 2 of the 3 steps there, what would be the distance that gets you 1 of the 3 steps? Well, wouldn't it be 0.4? So 4/10 of a mile, 8/10 of a mile. What would you have for a total distance then? What would be next if you add another 0.4 onto that? 0.8 plus 0.4. 8 and 4 is 12. It'd be 1.2. All right, so the total distance is 1.2 miles. I think that's the easiest way to do a problem like this. Oh, and by the way, 4 plus 8 is 12. You carry the 1 over here, and that's why that's to the left of the decimal point. You have more than 1 mile then total. So it's 1.2 miles is the total distance from his house to the ball fields. That, I believe, is the easiest way to solve this problem, by just making a little drawing like this. Another way you could do this is by writing a proportion. 2/3 of the distance to the ball fields. I can write that ratio, 2/3, is equal to, well, that 8/10 of a mile is not the total distance to the ball fields from his house. That's just how far he has walked so far. So that 8/10 of a mile is what part of the whole distance? I'll put an X there. And see, I can make a proportion. 2 out of 3 equals 8/10 out of what? And then you can cross multiply. X times 2, 2x equals 3 times 0.8. So 2x equals 2.4. See, 3 times 8 is 24, and then you move the decimal point in 1 space. Then you divide by 2 to finish solving this equation. And we find out x is equal to 1.2 miles. So that's how you could solve it using a using a proportion. So either way, but I kind of like that way of doing it like this, where you have 1/3 of the distance, 2/3 of the distance from his house to the ball park, right? The ball fields. And this is 0.8. So this must be 0.4. And then you can kind of figure it out. All right, add another 0.4, and where would you be? And that would also be 1.2 miles. So look at it either one of those ways. All right, that's it, everybody. I'll see you later.